All right, I think everyone's here, and I think I know pretty much everyone. But Anthony, okay, all right, let's get started. Welcome back, and I'm excited to see you guys all here. Yeah, after about 6-7 weeks in quarantine, kind of just staying home, but not going anywhere. It's good to be back. So some of you guys were here last semester and some of you guys were not. Um, so I'll briefly go through what we are doing here for this semester. Pretty much very similar to what we did last semester, okay? But on the course page here, you'll see on the days that we meet online, or if you have to be online, then you can find the Zoom link here. This is the syllabus we'll go through. So if you click on here, or I should, let me just try to open a new tab here. So right click on here and then open a new tab over here. So later on when we have homework assignments and stuff and exams, I'll post solutions over here under this panel. And then the lecture PowerPoint slides will be here, down here. Now this one is visible to you. The rest is not because we haven't scheduled those lectures yet. But each time before the lecture, you'll see a new one comes up. That will be the lecture of the next day. Okay, so you can kind of do the readings according to that one. New PowerPoint slide, which will specify which sections of the textbook we'll be going through in the next day. All right. And then once, if we have to meet online, or if some of you guys have to be online, then lecture will be recorded. You'll see then after lecture, a video link here down this. So after today's lecture, you'll see another link come up over here. Says we will say something like wave 01 YouTube link. That will be the lecture recording. You can review later. Okay. So this is what you'll see on the Moodle page here. Now let's go through the syllabus a little bit here and to just minimize that one. All right, so we meet Monday, Tuesday, Wednesday, Friday, okay? So 4 times each week in lecture and then 1 lab for each of you guys. You are either in the Thursday section or Tuesday section will be from 2:10 to 5:30 in this room, okay? So we are not switching rooms. If you want to find me in person, this is where you can find me. It's in this building 2 floors above here. Okay, so it will be on that side, south side of the hallway. If you go up there, you'll see that next to one of the chemistry labs. Okay, and then that's my extension number and my email address over here. Now, if you want to come to me during one of the office hours, you can see my schedule here. It's listed over here, but the times are listed here, but you can also find from my schedule over here. So basically, a lot of times I will be in this room, either teaching another class or lab sections, but otherwise you can find me during this time in the on Monday afternoons and Tuesday at 9 o'clock hour and Thursday 9 o'clock hour also, and Thursday 11:30 to 12:30 hour. Okay. So because of the situation we have right now, COVID pandemic, so we prefer to meet online via Zoom. If you have questions, you can send me an email, say you want to ask me a few questions at specific time, then we can meet online. Okay, so this is the Zoom ID. You can meet with me from the ID. Okay, so in your Zoom app, you just click on join meeting and then punch in these numbers there, and then we'll be seeing each other online. Also, sometimes if you just have like say short questions. The questions with very brief answers, you can ask me before class or after class, or during the lab sections, okay? Before or after, or um, during the lab section, I would prefer you finish the lab part first and then ask me question. I think for this semester's labs, a lot of them we can finish them say within 2 hours, and then the rest time we can try to work on if you have any questions, okay? um, right. Then other times, specifically, for example, you want to meet me earlier, like before 9 o'clock, you can let me know. We can also work on that. Sometimes if say we have like exam next week on Monday, something like that, you can also ask me to see if I have time to answer your questions during the weekend, okay? But just let me know beforehand so we can set that up too, okay? All right. So that's that. And then these are just a few informational items that are required on the syllabus. You guys can go through them for the disabilities services, title 6, 7, and 9, compliance, etc. Information's over there. For this class, this semester will focus on thermodynamics, waves, and sounds, and then also electricity, magnetism, and optics. Those are the main themes we'll be touching on. And then also here are just a few informational items about this class, the departmental goals, objectives, etc. Okay. Required materials. Now, if you didn't take physics 1 with me, so this is the textbook we are using at this university. We are using university physics textbooks from OpenStax. So if you can click on this link, then you can download the textbook that we need. Okay, so it goes here for the science. You may find like other textbooks like chemistry, etc., or mathematics here if you want other references. So for example, I know you guys learn a lot of math, taking a lot of math classes. There's also this free textbooks you guys may want to use as reference, but for physics, this is the one we use, okay? So for physics 1, we pretty much focus on the volume 1. I think we went from chapter 1 through 15. And then for physics 2, we'll be covering chapter 16 from volume 1, and then volume 2, and then also the first few chapters on volume 3, okay? So if you prefer to read a paper textbook, I would just recommend you maybe just buying volume 2 because that's the most majority part we'll be focusing on, okay? And then you can kind of print out just a few chapters from volume 1 of a few chapters, the first few chapters from volume 3. I think that will be most economic wise. All right, but you can download their soft electronic copies for each of these volumes for free from here, okay? All right, or you can view them online if you want. For the homework assignment, it will be assigned expert TA online homework service platform. So there's a link over here. You can click on this link. This will get you to register for this class, okay? So if you click on that one, it will ask you to type in your email address. Now, many of you guys had an account set up last semester. So once you type in your account here, it will detect your account already, and then you can just type in your password to go on from that point. Okay, you don't have to create a new one. But if you are new, then you'll have to create your password, etc. But just after this page, okay, the same here. So once you are registered on Expert TA, you get free travels for 2 weeks, okay? So if you are not sure you are going to stay for the class for the whole semester. Also, right now you can just go for free trial, okay? Or maybe your budget is tight this month, you can just wait for a couple of weeks and then do that too, okay? So yeah, and that's that part. And then there's detail at the end of this syllabus on how to get registered, okay? Again, topics to be covered. These are the small topics that we'll be touching on. Attendance, this is similar to previous semester. Okay, so if you feel sick, you can just let me know, and then you can join the class online if we are having an in-seat class that day. And if you are so sick that you couldn't even attend the class online, just let me know. Then you can watch the recording later. Then you'll be marked as excused absent for that day. Okay. But otherwise, if you oversleep, then that's an excused absent. Okay. So and then I think you guys know this. If you miss 2 weeks, that means if you are marked for 8 times of unexcused absences, then you will get email from the school, like a warning, say if you keep missing the classes, you will be disenrolled from the class. Okay. January 26th is the last day to drop a course without a W grade, and then March 12th is the last day to withdraw from the class. Okay. Those are the 2 days you might want to remember. This is a 5 credit hour class. Okay, so the time you spend on this class each week should be about from between 9 to 10 hours outside of class and lab. Okay, so there's a lot of time you need, a lot of effort you guys need to put in this class. All right, now homeworks. There's 3 types of assignments. Like reading assignments, you are not tested or monitored for that, but it's really your own benefit. Okay, so as I mentioned before, each class next day, then the PowerPoint will be posted online. You are responsible to check through what section will be covered and do the readings before the class. For problem assignment, that will be on the expert TA. Okay, you'll get about 12 homework assignments throughout the semester. So roughly like 1 assignment each week. Okay, so similar to what we had last time. Now, if you are new to expert TA, so for each problem asked, I believe there's 20 trials I set up that you can try without penalty. Okay, if you use up 20, then that's it. You have no chance to answer the question. Okay, but remember, even though when you try, even the system doesn't give you any credit, I can always check back and see if you can receive partial credit. Okay, so remember, even you don't get the correct answer, then you will be still partial credit later when I look into the system. Okay. Lab reports. So this is something that I think I'm doing differently from Dr. Park last semester. Okay. So for lab assignments, I will ask out. Yeah, I shouldn't say prefer. That's just this option. So you guys need to turn it in online through your Google Drive. So I hope everyone has a Google account. Okay, so if you don't, you can sign up for a free one. That's out of no charge there. So then you will have a Google Drive associated with your Google account. Okay, so if you type in drive.google, this is what your Google Drive look like. You might have much less stuff than I do. I have a lot of folders and then documents here, but you'll get this panel over here. You can create a folder just for this class. Okay, you can say add a new folder. So put say physics, maybe 2, This is second semester. Create a folder over there, and then it should be already here now. Now you can open the folder here. You can do your lab report in two ways. One way is to write your lab report using Google Doc. Okay, so that means you can create a Google Doc here, all right? And then you can write up your lab reports, okay? Lab title, objectives, etc. over here, and then data analysis, and then additional questions, answer to additional questions here. And then after you are done, you may want to give it a name, say, so here, say lab 1, whatever. I think we are doing waves for lab 1, okay? So set lab 1 waves. After you are done everything, you want to share it with me, okay? So click on share there and then put my email address. So this is the one that is different from in the syllabus, okay? But I have this information in the lab manual later on when we are doing the lab. This is the address you want to use, bhou@learn.mvnu.edu, okay? So you can type in that. This is a Google account, okay? This is not the school, the Microsoft account. This is a Google account, okay? And then you can give me permissions. So I just need commenter permission, okay? So that I can comment on where you get wrong or which data say it doesn't look good, things like that, okay? So just take that and then hit send. Okay, then I'll receive this in my email, and then I'll be grading through that. Okay, so in the grading, I'll just put comments on to your lab report. Okay, now this is doing it through using Google Doc. You can also make a lab report like Microsoft Word file. So say make a file here, say lab 1, okay? And then the same thing, like work on the lab report, etc. Write up data analysis, etc. After you are done, you open your Google Drive, maybe kind of something like this here, and then go to the folder that you would like this file to be. So let me close this one. So this is the folder, okay? My physics 2 folder. You will drag and then drop it here. So then it will be uploaded to your Google Drive, okay? Then go here. Now you can right click, then share, okay? Then it will be the same process as you share your Google Doc to me, okay? So type in my email address and then just permission as commenter here and then done, okay? So now I would ask you guys to, when you guys doing the data analysis, you need to use either Google Sheet or Excel spreadsheet for the data analysis, okay? So then after you are done with those spreadsheets, you also want to share them with me, okay? So the same way, if you are doing Google Sheet here, you kind of just make a Google Sheet and then copy your data over and then doing the data analysis there. If you are doing a Microsoft Express sheet, you're doing the same. Then after you are done with that, you will also share those two, those like spreadsheet files with me, okay? So that's on the lab report, how you want to turn it in, okay? Now, after each lab section, you have 5 days to turn in your lab report, okay? So this might be different from what you guys had last semester. You think you guys had like 1 week, okay? So this is 5 days, okay? Different. A lot of times you can finish a lab report just in the lab section, okay? And then just finish it and then you don't have to worry about it. But a couple of cases, a couple of labs, I think you might need more time. So then you'll work up to the lab sections for the lab reports again and turn it in, okay? All right. So this is on the lab report. So typically, let me show you guys like a kind of what it looked like for a lab report typically. Okay, so let me pull up one here. All right. So this is something like one of the lab we did last time. So you will have a title of it, okay, in your lab report, and then date, okay, and then I think another one you need is your lab partner names, okay. So lab partners include both partners names or all. If in some cases you have to work, 3 of you guys will work as one group, and then put all 3 names, okay. So the names there. And then list the learning objectives of the lab. So this is in the these are in the manual. You can pretty much just copy and paste over. Okay. Summary is a few sentences that you summarize what we did in the lab and then what did you find out. Okay. And then the table of results. Let me see. Right. And then additional answers to additional questions down here. I think this lab report, maybe not a typical one you should have. You should also include your data tables. So this is another, let me see if there's another one I can pull up. Okay, so something like this one. Now, this guy prefer to turn in a PDF. That's fine too. If you want to turn in a PDF, that will work too. Okay, but partners, names, date, and objective summary, and then data tables. Okay, 1 and 2, etc. And then there's a plot that is asked. So you can include your plot over here, and then table of results, etc. here. Okay, answers to additional questions. So this is a kind of example how a lab report will look like. Okay, you might have different numbers of data tables and table result, but this is pretty much is the format. Okay, and I just need one report from each group. Okay, so that'll be enough. All right, and then you guys can divide up who is writing up the report, who is doing the data analysis, or etc. Among yourself. Okay. All right. And so your final grades will be coming from these 4 different parts, or actually 3, I would say. So 20% from the homework assignments, and then 20% from your lab. There will be 3 midterms and 1 final. So 4 exams in total. Each exams they are the same 15%. Okay, and then similar to what we did in physics 1, each exam will be just focusing on certain chapters that we cover in the past a few weeks after the previous exam. Okay, so but it's still kind of cumulative because we will use like concept from previous chapter as well, but there's a focus on certain chapters. Okay. The final grades will be assigned according to this table, the same as last semester, but you need to have like 90% or more to get an A, and then 86 to 89 will give you an A minus, etc. Okay. All right. And then this last page here is the detailed instruction on how to sign up for expert TA. Okay. Now, there's a good chance that some of you guys might be missing like 1 or 2 labs, okay, throughout the semester, due to like either sickness or some emergency or had be in quarantine, etc. So we do have a few like makeup weeks, okay? You guys can wait and then make up your missing labs in later in the semester, okay? Or ask me because I also have lab sections for general physics too on Wednesdays and Fridays, okay? They're kind of having a different schedule than us, but chances are you might be missing one of the lab that you can make up over there on their section, okay? So just let me know and then we can work on that, okay? All right, and then also we don't have lab this week. So that means on Thursday for you guys sign up on Thursday for the lab, we don't meet, okay? But starting from next week, we'll have our first lab, okay? Yeah, trying to think if I miss anything important. But you guys have any questions at this point? Yes. Right. Yeah, you have to do it again. It's the cost is per semester. Yeah. But you can keep your old account. Yeah. You have to use a link here, the specific link here. Okay. Click on this one to get registered. Okay. Any other questions you guys might have? All right. So if not, then I think we should spend some time on some of the list chapter 16, okay, for lecture. If you are new to my classes, then so on my PowerPoint slides, you'll find there's this short URL here, which you can actually use to quickly get to the PowerPoint slides. Okay, so and you are also allowed to use your laptops in my class. So that's something you can type in your web browser's address bar to get access to this one, because later on we'll be doing some like in-class exercise and you guys can click on the PowerPoint to submit your responses there, okay? For each class, I need 2 of you guys to do the disinfection. So basically just spray off the number 7 disinfecting solutions on the surface of the class. Okay, so today I need Isaac and Nathaniel to do that for us. Okay. All right. And then homework number 1 will be available at some point today, later today. Then it's due next Thursday. Okay. Again, you want to get started working on your homework problems as early as possible, because if you wait until the last day, chances are you wouldn't be able to finish all the problems, okay? Because I think most of them are kind of challenging and require some time to finish them, okay? All right, so chapter 16 on waves. So for this class, we'll focus on mechanical waves, okay? And then we'll get to types of different waves in a little bit. But a wave in physics is defined as a disturbance that propagates or moves from the place it was created, okay? So for example, the one we usually see like in a lake or something like a pond, if you throw a rock in there, then you'll see wave being created, right? It's like water wave there. And then also more complicated waves like gravitational wave, like this one here on the right here, which was first detected a few years ago by LIGO. it's also a wave. Okay, this is the merge of two black holes. Okay, so this is just an image that he created for us to better visualize the real gravitational waves. They are not visible. Okay, so but yeah, just kind of help us understand it. All right. So the focus of us here in this chapter will be mechanical waves. That means the ones that are governed by Newton's laws and require a medium. A lot of waves, they do not require a medium. So for example, gravitational waves, they don't, okay? And then electromagnetic waves, like your cell phone signals, they don't, okay? Wi-Fi signals, they don't, they can propagate in vacuum, okay? All right. So types of waves, mechanical waves, electromagnetic waves, and matter waves. Okay, so those are three major types. Electromagnetic waves, we are using them a lot. So like Wi-Fi signal, radio signal, or cell phone signal, etc. Matter waves, you don't get to deal with that a lot, but it's the foundation for quantum mechanics. Okay, now a lot of you guys might not have to deal with quantum mechanics. Okay, but that's the foundation of the matter wave. So basically it says a matter when it travels, it can also have a wave property. Okay, so that's the matter wave duality of matter. Okay, but that's not focus of the class here. You can generate a mechanical wave like if you are just moving one end of the rope up and down, and then the other end of the rope is fixed over here, and then you kind of generate a mechanical wave. Okay, so this is one type of mechanical wave. Also, like the sound, the fact that you can hear me is because I'm creating this wave through the air. All right, so I'm moving the air molecules back and forth, and then it reaches to your ear, and you can hear this. So this is the same thing as a speaker. When the speaker plays sounds, then you hear it through the air there. Okay. For mechanical waves, there are two types of waves depending on the way they are propagating. So the first one is called transverse wave. Okay, so this one here on the left here is called a transverse wave, where the media actually oscillates perpendicular to the direction of the wave is propagating. So the wave goes from left to right, but the media that carries the wave as goes up and down, up and down. Okay. The second type of mechanical wave is called longitudinal waves. So where the wave propagates from left to right, and then at the same time, the media moves like in that same direction back and forth again. Okay, so this here, slinky here goes back and forth, okay, to propagate the wave. So in the previous figure, when you have the wave in the stream, that's a transverse wave. And then when the sound wave propagate in the air, this is a longitudinal wave because the air molecules move back and forth along the direction of the propagational wave. In this scenario, the media of the rope, particular point of rope just go up and down, It doesn't go back and forth in the horizontal direction as the wave moves. Okay. All right. So one conceptual question here is, if you go surfing, if there's a wave coming, or if you go to a sports event, which we are not allowed to this time, but if the clouds generate a wave, okay, then the question is, do you move along in the same direction? Now, if you on this page of PowerPoint slide, you can click on this and then you can submit your response to this question here. It's a yes or no question. Okay. Let me see what you guys think. All right. So I see most of you guys says no. All right. And then some of you guys says yes. So we can take a look here. Um, so in this two types of waves, and they are the same, actually the same type of waves. Okay, they are transverse wave. So just imagine if you are going to a stadium, when you are part of the wave, cloud wave, then you kind of just stand up and then sit down, right? You don't jump to the next seat, right? Or sometimes maybe you do it when you get too excited, but usually you don't, okay? So the answer to this question should be no, you don't, because this is should be a transverse wave. You just go up and down, but the wave goes just in the horizontal direction, okay? The same here, if you go surfing over here, you just go up and down, and then you stay here, kind of, more or less, okay? All right. Now, for a wave, there are a few terminologies we need to get familiar with because it's a wave. So then we might be interested in like what's the wavelength of it. Okay, so this is the first one, or the first one, it's the period. That means the time for one complete oscillation up and down. Okay, of the motion in the wave. It's called period. Or the time it takes for the wave to travel from one peak to the next peak. It's called period, okay? We use symbol T, capital T, typically. Now, the distance from one peak to the next one is called the wavelength, okay? So this is, we usually use lambda, okay? So this looks like, this is a symbol called lambda, okay? And the amplitude refers to for the median here to go up and down to its equilibrium position over here. So this is the maximum displacement of the median from the equilibrium position called amplitude, capital A. All right. The speed of wave then can be calculated by doing the distance divided by the time it takes for one period. Okay, so distance the wave travel in one period of time is lambda. The time it takes is the period, the capital T. And it's also equal to lambda times the frequency. So frequency then is defined as inverse of the period. Okay, 1 over T will be the frequency F here. All right. All right, let's take a look on two exercise problem here. Let's do this one and then the one after this slide, okay? Should be easy ones. So this first one says, if you were to shake the end of a taut spring up and down 10 times a second, okay? What would be the frequency and period of the sinusoidal wave produced on the spring? So if you do that, if you shake the string up and down 10 times, then you actually generate a sine wave, okay? What are the period and the frequency? Again, you can click on the problem here so you can submit your responses. You click on that one, it will give you this. You can submit your response there. All right. Yep. So I think you guys got this right. So the frequency should be 10 hertz. Okay. SI units for frequencies hertz or second inverse, but they are the same. And then the period should be 0.1 seconds or 1/10 of second. Okay. So that's correct on this one. All right. Good. Let's take on the next one here. So this one says a sine transverse wave has a wavelength. So lambda is 2.80 meters. And then it takes 0.1 second for a portion of the string at position X to move from a maximum position of 0.03 to equilibrium position of 0. So the maximum position away from the equilibrium, that should be the amplitude. Okay, so that's capital A, the amplitude is 0.03 second. So then what are the period, frequency, and wave speed of the wave? It also tells you it takes 0.10 second for the portion of the string to move from maximum to equilibrium position. So you want to draw the sine function and then see what is that corresponding to the period, okay? All right, I think I see a few responses in here. Most of you guys have the answers correct. So if you have a sine function, this is what it look like, okay? So a sine starts from 0 at the origin here and then goes like that, okay? So it tells you that the time it takes from a maximum to equilibrium. So that means this is maximum to here. This is the equilibrium over here, okay? It's not the end over here. This is the also another maximum here down here. So this is the equilibrium position, but maximum to one side and then maximum to the other side, okay? So then time it takes from here to here, it's just this part of it, small t. So you can figure that for the whole period, that means from one peak to another peak, okay? So this is a peak, this is a valley, okay? So from here to here, this would be, the capital T then would be 4 times of small t, right? This is just one t, and then go from here to here is another t, small t, and then small t here, and small t there, all right? So your period should be 0.40 second, okay? And then now, once you have the period, then frequency you can calculate. Frequency is 1 inverse of the period, which will give you 2.5 hertz. Okay, for the frequency there. And then it also tells you the wavelengths, I think, in the problem. So it tells you wavelength lambda is equal to 2.80 meters. So then the speed of the wave will be lambda times wavelength, or lambda divided by period, either way, okay? So this is 2.8 meters times 2.5 hertz, which gives you 7 meters per second, okay? Because hertz is 1/second, okay? So then meters over second for the correct unit for the speed, okay? All right, I think most of you guys have this one, right? Let me know if you have questions, okay? So if you are online, you can unmute yourself because default is mute. All right. So since you guys are clear here, let's move on here. So again, this is for longitudinal waves. The displacement of the median is along the same way as the propagation, okay? But the median goes back and forth, okay? It doesn't travel from here to here. It just go back and forth here, okay? Confined in one period of the wave there, okay? And the same for the slinky here, okay? All right, so the next we'll briefly take a look on the mathematics of a wave, okay? So for example, imagine if you have a wave traveling in a stream. So this is what it look like if you just shake the stream up and down one time, then you'll create a peak, you'll go in that direction, all right? So this is the lambda, the one wavelength. So this is the minimum, this is the maximum, okay? So you have to look at that way. So in this case, if you generate a wave in a stream, it's kind of either a sine function or cosine function, okay? So let's take a look here. In the previous chapter, the last chapter we talked about in the first semester, that when we have an oscillation motion can be described as a sine function or cosine function, okay? So for the convenience, we just look at the cosine function, but you can do the same as a sine function. So they are the same functions really, just with a shift of from like by pi or 180 degree, right? So sine function and cosine function basically they are the same function in that sense. All right, so a wave looks very much like an oscillation motion, right? So for oscillation motion, it goes back and forth, back and forth. Then when you trace the position as a function time on the curve here, then it looks exactly like a wave, okay? So in that sense, when you create a wave in a stream, so this is something you guys will be doing in the lab. Okay, in the lab, you'll be giving a electric vibrator. So this is an electric vibrator. You vibrate up and down, up and down. So that's similar like when you are shaking the string up and down. When you are doing this, then you create waves in the string here. Okay, so this is just the beginning. When you create one wave, when t is equal to t, capital T period here. Now, if you keep the power on here, this will keep vibrating. Then you generate more waves in the string. Okay. So then you'll have either a sine function or cosine function here at any given moment. Okay. Then you can express the wave, the displacement from the here, the equilibrium point is a function of x. X will be here, the time x is over here, okay? So you can use a sine function or cosine function. Again, this is just a preference of the author, okay? Some author would just use a cosine function, some author would just use a sine function, okay? So let's take a look on the sine function in this case, okay? Just to give you a sense that you can either use either sine or cosine, because in the previous chapter, when we see oscillation motion, we use a cosine. Now let's turn to sine function this time. All right. So this is why you can write the amplitude is the maximum displacement of any point of the string away from the equilibrium point. Okay, so this is A. All right, and then sine of 2 pi over lambda. Lambda is the wavelength. Okay, x will be this. Okay, or this guy. Okay, so either way, it's a theta or this way, whichever you are looking at. Okay. For a wave function, so it propagates from one position to another position. Okay, so then it should be also a time of function t, right? Because as t varies, then the position varies as well, okay? So to include t in the equation, then you write the position of any point of the median as a function of the position horizontal wise, okay? So this is the position in the y direction. Yeah, so the position in the y direction for any point of the string, it should be a function of its horizontal position and then time t, okay? And you can write it as a sine function. So A, the amplitude times sine of 2 pi over lambda, this is the wavelength, and then x minus vt, okay? In the parentheses there. That's the wave function, okay? If you distribute the 2 pi over lambda into the parentheses within the bigger parentheses, then this is what you get, okay? So this is 2 pi over lambda times x minus 2 pi over lambda times v times t, all right? Where 2 pi over lambda is called wave number, or k. If you see k in this function, that means 2 pi over lambda, okay? That's wave number. And it has a dimension of meters inverse because it's a constant number divided by the length, lambda, okay? So that's the dimension there. All right, and then in the previous chapter, if you need to review it, you can check that one. So when we say omega is equal to 2 pi divided by period t, it's also, that's called the, does it name has a name? Yes, it's called the angular frequency. Okay, so angular frequency is 2 pi over t, and then usually you can write as symbol omega. So omega, that's the symbol. It's called angular frequency. Okay. Now keep in mind omega and f, they are different, okay, quantities, because one is angular frequency, one is frequency. The relationship between the two is omega is equal to 2 pi times frequency. Okay, so omega equals 2 pi times f. All right. Now the sign here in the sine function a sine kx if it's minus omega t, that means the wave is going in the positive x direction, okay? So if you have a positive sign in the parenthesis, if you take the positive here, that means this wave is going in the negative x direction, okay? So pay attention to the signs inside the parenthesis there. And in physics, the speed is defined as lambda divided by t in terms of wave number and angular frequency. It's angular frequency divided by k. If you know omega, if you know k, then you can also calculate the speed, okay, of the wave. So it's omega divided by k. Let me see. All right, so this is the recap of the chapter 15 when we have the oscillation motions, okay? You can see as a time of function, the position of the oscillator, the mass, point mass is differently. Now, a lot of times, this is kind of simplify sign function, okay? Because a lot of times you do not necessarily your starting point is not necessary at the origin, okay? Just like when we talk about this one here. So you are actually starting from about -1 here in the position, okay? And then goes there. If that's the case, that's a general case, then you also to include a phase factor here or phase shift here called phi, okay? So then you just add phi to the terms inside the parentheses, okay? So let me see if this is in the next one here. Okay, so in the next one here, so similar to when you have oscillator, so you add phi here for the phase, okay? So that's the additional term in the parenthesis here. So there are 3 terms inside the parenthesis of the sign function there. All right. That's just because you don't necessarily start from 0 when t is equal to 0, okay? All right, and then I think we'll leave these 2 slides Friday. So basically, this is the first equation is a position. Then when you have position equation, you can derive the speed of the velocity and then acceleration, okay? So that's from that point on, okay? But we can come back on Friday on those. All right.